Okay, welcome to the first free response problem. We are going to be looking at a probability type problem. Okay, so first let's just read the problem. A system has two components that operate in parallel. Because the components operate in parallel, at least one of the components must function properly if the system is to function properly. Then they give us a table giving us the probability of component 1 working, component 2, and then components 1 and 2. This means both are working at the same time. Okay, let's get started. Part A says create a Venn diagram which properly represents this information. Well, first I need to figure out what kind of Venn diagram am I going to create. So I have two options. First option is disjointed circles, and second option is overlapping circles. Okay, so if my circles are disjoint like this, like not overlapping, this is only the case if my two events are mutually exclusive. And this is if not mutually exclusive. Okay, probability speaking, in this case, the probability of 1 and 2 would be 0. This and being the overlap. There's no overlap here. Here, it would be the probability of 1 and 2, not 0. Okay, so if I'm looking up here, this probability is my probability of 1 and 2. The probability of both are happening at the same time. Since this is clearly not 0, I'm going to use this Venn diagram. Okay, so let's draw out our Venn diagram. Okay, let's call the circle on the left 1 and the circle on the right 2. And the section in the middle is the both case. Okay, well first they tell us that the both case is 0.72. Okay, then they tell us that the probability of component 1 is 0.8. Well, on my Venn diagram, this blue circle is the probability of component 1 working. Okay, well, what I want to find is what is the probability in this section, this crescent moon part of the circle. I found this section, so to find this, they both have to add up to be 0.8, and I know this part is 0.72, so this part has to be 0.08. So this one has to be 0.72 plus 0.08. Okay, same thing on this side. This whole circle is component 2, and I want to find this part right here. Well, I know that all of component 2 is 0.9, so that has to be 0.72 plus, and we can see that would be 0.18. Okay, what is represented by these crescent moons is this right here is the probability of only 2 working, and this crescent moon is only component 1. Okay, we're not done yet. We have to make sure we've covered the case where neither of them are working. So let's check what all of our probabilities add up to. Okay, that is not 1. Everything has to add up to be 1. So I'm going to find out what's left over, and that 0.02 becomes this part. This part being nothing works on the outside. Okay, now I've got my complete drawn out Venn diagram. Okay, what is the probability that either component 1 or component 2 are working? So let's write out in probability notation 1 or 2. Okay, well I know the probability of 1, this is the probability of 1 plus the probability of 2 minus the overlap. Okay, well we know all of this. Probability of 1 is up here. Probability of 1 is 0.8. Probability of 0.2 is 0.9. And this overlap, which is the both case, so what I'm doing is I'm adding this circle up plus this circle minus an overlap because I double counted it. Similar to whenever we were working with cards and we were trying to figure out the probability of a face card or a heart. There are some cards that are both faces and hearts, so we have to subtract the cards that satisfy both cases to make sure that we don't double count them. Okay, so let's plug this in my calculator really quick. 0.8 plus 0.9 minus 0.72. I get 0.98. So I have a 98% chance that component 1 or component 2 are working properly. Okay, part C. Given that the system is functioning properly, what is the probability that only component 2 is working? Okay, I underlined this word because that gives me a key to think that what is the probability, and I write out this given case. Okay, so this line tells me what's given here. Okay, what's being given is the system is functioning, and given that it's functioning, what is the probability that it's only 2? Okay, so what's being given becomes the denominator of my function. So the probability that it's functioning, and my numerator becomes the other part. Okay, the probability that only 2 is working is this little portion that we found here. And the probability that it's functioning is the part that we found here in part B. So if component 1 or 2 is working or both, that means the system is functioning. So, representing by this Venn diagram, this is the only part where it's not functioning. This is 0.02. Okay, so that would be divided by 0.98. And I just plug that into my calculator. I get 0.18 divided by 0.98. I'm going to round to 3 decimal places. So I get 0.184. Okay, last part. The system only operates at full capacity when component 1 is functioning properly. The system operates at reduced capacity when the system has to rely on component 2. This means that component 1 is not working. What is the probability that the system will be operating at reduced capacity? Okay, so the probability that it's reduced capacity means the probability of component 2 is working and component 1 is not working. So only component 2 is working. Okay, well we already figured this out. Only 2 is working. Right here, in my circle here, 0.18. So my probability that the system is functioning at reduced capacity is 0.18.